What's good, SPSS fans? I just want to show you a little bit of an extension of what we talked about previously. Hopefully you've already viewed the Understanding Variability lecture that was provided. This one kind of builds off of that and talks more about normalcy and normal distribution. So just a quick walkthrough again. If you go to Analyze, same data set, by the way, that we're always using, car sales data. If you're kind of tired of it, I'm sorry. I love this data set because it's just very applicable in a variety of contexts, real straightforward to use. And to be very honest with you, I'm a massive car guy, so anytime I can incorporate cars into anything I love, we're in business. So if you go to descriptive statistics and frequencies, once again, to run a histogram, I'm going to back out sales in thousands, and I'm going to drop in something like, let's say, fuel efficiency. We should see some good clustering with that. Okay, I leave the stats on. I've got mean, median, mode there just to give me an idea of where they fall. And then charts, once again, I'm going to run a histogram, and I'm going to look for my normal curve on the histogram as well. So I've got a basic comparison. I can hit continue, and I can hit OK. And once again, here we go. We start with the mean, median, mode, and what we see here is they're very tightly close together like this. Not exactly the same thing. A mean of 23.84, a median of 24. So we're very, very close there, and then a mode of 25. So they're all pretty darn close together, which is really nice. It's going to help with the normalcy of the distribution. Just to refresh too, N is the number of cases we have in this data set. There's a total of 157 cars. 3 of them are missing the data points for fuel efficiency. That's what we're seeing here. So 154 cars were analyzed because 3 don't have data for fuel efficiency. A frequency table just below that, you can see it laid there. And then if we scroll all the way down to our histogram, we have the data set laid out visually. All right. So as always, we've got the normal curve there in a solid dark line like this, to give you an idea. And to be very honest, actually, our data fits normalcy pretty darn well in many ways. So if I can show you in this case, the normal distribution here, we've got the table, or rather our data set, following the curve pretty well. We do have a pretty extreme middle bar in this case. So it does kind of follow that a little bit higher than it normally does. But if you look, see, we have the actual bars following a normal curve on the back end like this here too. So it's actually pretty darn close to what I would consider a normal curve. Once again, though, we have this outlier. This outlier here is really kind of throwing things a little bit sideways. That kind of can disrupt our otherwise normal distribution. And if we look too, that outlier is going to be this one car right here. Here's the frequency distribution. So you'll notice the miles per gallon jumps from 33. You've got 4 cars getting 33 miles a gallon to 45, which is obviously really good gas mileage, but just one car getting 45, so 12 miles more, and there's only one car there. That's what we refer to as an outlier, as we talked about previously. So this outlier is really kind of otherwise messing with a fairly normal distribution here. Couple of things I want to point out for normalcy. There are 3 things that I need you to know for a normal distribution. A normal curve is 1, symmetrical. Right? So it's going to be symmetrical. So it's going to have this center point like this, and it's going to be symmetrical on either side. Okay? It is going to have what's referred to as, it's going to be asymptotic, right? In which the term asymptotic simply means that the curve will get closer and closer down to the 0 value on either side, but never actually touch the line, never actually reach 0. So if you think back to when you maybe took pre-cal or something like that, when you would see the parabolas or the sine curves and things like this, where they would approach a value but never actually touch the value. Same kind of idea. The third thing for a normal distribution is that they are going to have the mean, median, and mode be the same value. That is of critical importance. So right here in the middle, right here where it should be the very apex, where my cursor is right now, that should be where the mean, median, and mode all fall. So in this case, they're close. They're very close. As I said, I'll scroll back up. For ours, it's getting pretty darn close. 23.84, 24, and 25. So ours follow a pretty close pattern with that. Can't describe it as completely normal, but you could do worse. You could find much less normal data. The distribution for this one looks pretty clean. By comparison, let me just show you a very not normal distribution, or abnormal distribution, however you want to describe it. So if I take out fuel efficiency and drop in something like, we'll say sales in thousands, right? And hit OK. What we see here, down at the bottom, ta-da, right? A really unusual curve, in this case seriously positively skewed, where we have a ton of values down here down the low end, and then it kind of just tapers off going this direction. So what we would call a very serious positive skew. But you can see the contrast we're dealing with here. This one doesn't come anywhere near normal, whereas the one we produced previously is getting a lot closer to what we could consider a normal curve. These are just going to be visual indications of how the data is distributed and how well this follows a pattern of predicted normalcy.